I'm Marcus Hansen. I work for Sony Develop World. So I usually go to all these DroidCons. And this is Johan, who's going to hold a session here about interface and how you can boost your app. And in the end of this session, we want to give away a nice Sony experience, have to say. And a Sony smartwatch. So be sure to stick around until the end. And we're going to keep this short and sweet because we have to catch our flight. And we know that the Paris traffic could be a problem. So we promise we won't go over time. So without further ado, here's Johan.
All right, thank you. Like Marcus said, I am Johan Henricson. I work at Sony Mobile in Lund at the UI department. And I'm here today to present to you a few best practices for boosting your app's UI, essentially making your app better by making its UI better. I'm not going to go into too much detail on any subjects. I'm just going to scratch on the surface, introduce to you a few things to think about and some techniques to perform them. I hope to plant a seed for inspiration and further studies. So I'm just going to get to it because we have a flight to catch, like Marcus said. So I assume most of you guys have an app or two out there, or at least a killer idea for one that will make you filthy rich and famous. So I'm going to help you achieve that. So if you look at top apps on various stores, there's a few characteristics that separate good apps from great apps. So top apps typically fulfill a need to get started with. It solves a problem to the user, or it's really entertaining. Top apps are reliable in terms of stability, performance, consistency, just simply a trustworthy application that you can trust. They're really likable, easy to use, easy to learn, and they usually have a strong visual identity as well, so it's easy to recognize them and remember them, which means you will use them regularly. So, as you know, this is a session with a focus on UI. So we're going to look at how we can use some UI tips and tricks to improve in each of these areas. First subject is signature UI, or a custom UI, that is, something that's out of the ordinary, that sticks out to help you solve that specific problem or to just look good, basically. Perceived performance is another subject that we'll touch upon, how to essentially make your app seem as fast and as snappy as it possibly could. And we'll also touch upon the subject of animations and transitions, also to make it seem as good as it possibly can. So each of these map towards one of the characteristics there. And for the last one, the strong identity, both the signature UIs and the animations and transitions apply. So that pretty much sets the agenda for this presentation. So we'll go through each of these areas, and then I'll have a quick wrap-up, and there will be time for a short Q&A in the end. So since we have a Q&A in the end, please do hold your questions until then, and I'll be happy to try and answer them. Okay, so the first one, perceived performance. Perceived performance, actually let's start to reflect, I'm not sure how many of you are familiar with the word of the concept of perception and perceived. Perceived is really a key word within interaction design, and when you talk about UX, it's actually less about how stuff looks. No, it's more about how stuff looks. It's less about what things actually are and more about how they appear. So in this context, it's about how well performing your app seems to be. Because at the end of the day, when you hand your app to an everyday user, they're not going to care about how great your architecture is or how well implemented protocols you have. What appears on the screen is what matters. And the golden rule, the first and golden rule in terms of perceived performance is that everything shall be smooth. It has to do with human perception, really. As soon as something transitions and moves smoothly or just works smoothly, it seems like it was meant to be. Because, you know, in the real world, if I drop this bottle of water, it will not be here, and then the next frame it will be on the floor. It needs to perform. It needs to transition from one state to another, right? So if something is smooth, it seems like it was meant to be. If it's sudden or uneven, then it seems like it got stuck and it's just broken. So this is really important to think about. And I also want to, yeah, I did touch upon the difference between perceived and actual performance there. Obviously, there's a strong correlation between the two. And the reason why I want to spend time with this is first and foremost the general impression. If your app feels laggy and starts to drop frames, it's going to feel like it's on the verge of breaking. And if it's bad enough, it actually will break. It will cause ANRs in your application, which causes you to lose data and or context, which is obviously not a good thing. On the other hand, if you do this well, you will have a quick and snappy UI, which will allow the user to build a strong mental model and essentially understand how your application works if you do this well. So I'm going to show a few quick examples. This is a silly little application I made to demonstrate what I'm talking about. So it's essentially a list of French wines. That's me sucking up to you. So in the first example, we have a standard list view as you would normally interpret it. So it's just basically an adapter feeding some views to the list view, showing them. You can scroll around. Nothing happens. So if you can do this, congratulations to you, then you don't need this. Then again, in the real world, everything isn't always as nice and tidy as this. So what if there were short delays introduced? Say we get this data from, maybe we calculate it in runtime, maybe we get it from the internet or whatever. So in this second example, I've introduced a short delay of 150 milliseconds. Actually, it's a randomized interval from 0 to 150 milliseconds for each get view call. So each time you need to have another line to put on the screen, you have to wait for 150 milliseconds. So as you will be able to see, it's not a lot. 150 milliseconds isn't a lot. But as you can see, it twitches quite. This is not nice. This isn't doable. And in an unordered list like this, you may even lose track of whether you're scrolling up or down. And it's really hard to find something in this list. It's one thing when you look at it like this, but if you were going to use it, it's totally unusable. You'll never find what you're looking for. So one easy and fast way to do something about that is to make the loading of the items asynchronous. So in this case, we have the exact same scenario, except that the calls to get view aren't made on the UI thread, on the main thread. They're spawned off in a new thread. So as you'll be able to see, this one will feel as smooth as the first one. It essentially is as smooth as the first one. And as you see, if we start scrolling faster, there will be some items that are actually empty, but then they are filled up over time as the data is read. So what we've done is we've done this more cleverly. Actually, the actual performance of loading the items and getting the items on screen is the exact same in the third example as it is in the first, but it does feel a lot smoother. It just feels better. I hope you agree with that. So that's the first step that you typically would take. If you have some heavy stuff, just don't do it on the UI thread. And that's That's with a rather short delay. So maybe you have worse delays. This one has tenfolded. It's up to 1.5 seconds delay. And the asynchronous loading still works well, as you can see. But it does look a little bit choppy when those items appear after that 1.5 seconds. So it's still very noticeable that you have a delay in your application. And obviously, we can't do anything about that in the UI. What we can do is make it look a little bit better and a little bit smoother. So in this last example, I've added a little animation so that when the items do load, a short animation is loaded to make them appear. Just a smooth fade and scaling going on there. Just a really simple thing just to show the concept. So what we've actually done between these two items is we've made the performance worse, the actual performance worse. We've actually added about 100 milliseconds to the loading of each list item, but most would agree that the second one is more pleasant to use. Once again, if you hold it in your hand, the effect is even bigger than this. So that's quite interesting. So that's about the difference between actual performance and perceived performance, and that's really what perception is about. So to sum this up, the asynchronous loading and the animations, those are two sometimes very handy tools to cover up for a crappy backend. Obviously, you want to do something about the backend if you can, but that's not my department. And of course, in a real world example, if you have an application with this kind of delay, preloading and caching would probably be a good idea. So you don't have to reload every item every time. So essentially, the first step you do when you want to improve your perceived performance is to try and fix your actual performance. That is, of course, the first step. No matter how hard you try, you can only cover up. You can only do so much. So first step, of course, is to rule out all the usual suspects, like the database calls or services, threads, whatever, to reduce the load on your application. The second part is about that precious UI thread. You really need to cherish that UI thread. The key message here is, if you're not going to take away one message from this part of the presentation, it is do not run crap on the UI thread that could have been done elsewhere. That is so important. I'll say it once more. You do not run crap on the UI thread if you can do it elsewhere. As simple as that. You'll be a long way with that. And by doing so, you're giving yourself a chance to have a good responsive UI that doesn't lag, that's responsive to the user and to the system, and for a sweet UI, basically. Synchronous and asynchronous operations, you need to do that wisely. There's a bunch of synchronous ways of doing it asynchronous. You have your regular threads, your handlers, async tasks, and your services. I guess you're familiar with those. If you're not, you'll be able to look it up. I'm not going to go into detail on those, but they have a few different purposes, so choose the right one. And the nice part about this is that you can do it usually without rewriting so much of your application. It's a pretty cheap approach. Usually you can keep the main structure of your application. You can just thread this off, and instead of just doing nothing until you take that next step, you can wait for a callback from the thread. And if you find yourself in trouble here, it's usually, if you think this can help you, it's usually because you think you're dependent on the reply from the asynchronous task before you can go on in the UI thread. And that might be the case, and there are special cases. There are middle roads where you have to load a small portion of your stuff in a synchronous fashion before spawning off the thread and getting something back. So you really need to take this case by case. Right, so the summary. Keep the UI thread free. As I said, if you're going to take away one thing, that's the one. Do as much as you can in a synchronous fashion. Do stuff in the right order. Preloading and scheduling is really key as well. What you don't want to do is get lost among your threads and your tasks and introduce deadlocks, or even worse, start to imagine something worse than a deadlock perhaps. But there's all kinds of sorts of weird behavior that you may introduce if you don't have your threads in order. You have to, of course, make sure that your objects, the touched objects, are thread safe, so that you don't read and alter the same properties from two threads at once, because that may cause all kinds of weird behavior. Right, so that's all for transitions and animations. No, that's all for perceived performance. So we're going on to transitions and animations. And the purpose of transitions and animations is pretty close to the last one. And let's start looking at the definitions of the word here as well. The purpose is quite the same as with perceived performance. It's to make your app feel as alive, responsive, smooth as possible, and to help the users understand what's going on in the application. I also want to clarify that when I talk about transitions, I'm talking about moving from one context to another, typically an application switch, or moving from one big fragment to the next, or something like that. Whereas animations refer to changes within the same context, so typically a button coming, going, or moving around, or something like that. You basically apply those to views. So a few video examples again. This first one is from Google Keep, which I'm sure you're familiar with. So as I reorder my to-do list here, you'll see that not only the item that I'm actually moving around is being affected, but also the other ones. The one above it is being pushed up, and the ones below it is being pushed down. Really nice, really simple effect to make this look smooth and nice. You get this little wavy effect. If this would just twitch, it might be A, confusing, and B, really ugly. So that's a good example of where you could use it. So this is typically a layout animation, or layout transition, actually. And the next example is from our very own home application. As you'll be able to see, I'm trying to move this shortcut here to the Walkman player. I'm putting it on top of a widget. Now we don't allow that because it would be confusing. So when I let go, it just jumps back to where it was, and it also takes me back to that context. I understand what's going on. Had that not been the context, actually I'm going to play that one more. It's a short one, so if you see the beginning there. Had that effect not been there, it would be confusing to understand what's going on. I mean, I'm releasing it. I want it right here. Where did it go? And why am I in this weird scene? So those are two examples of that. How transitions and animations can show you how to make it smoother and also how to get a better understanding of what's going on. So transitions and animations. What you want to think about here is as soon as something changes on the screen, as soon as something comes, goes, changes, you should think about whether you should and how you could make that move to avoid these sudden drops, going from one frame to another, stuff moving or disappearing a couple of hundred pixels. And also, yeah, as typically when stuff enters, moves, changes, or when a state changes, a visual thing, maybe a switch going from an on to off position, or a container expanding or collapsing or something like that, you may want to do that, or you will want to do that in an animated fashion. What you should think about when designing and implementing your animations is pretty much the same as before, the perceived performance and the believability. I'm coming back to that because it's really key in all of this. You'll want to think of this not being pixels, but actual mechanical objects being moved around. You're sort of mimicking the imperfections and the inertia introduced by Mother Nature here. That's what we're dealing with. So in the same sense as I said, the water bottle cannot instantly drop from here to here. It has to transition. It has to move away. So in order to make this believable, you may want to mimic that behavior. Think about physics and stuff like that. And you may also use this the other way around, of course. If you want to visually indicate that something happened, that something appeared, then you want to do what they did in the Google Keep. You want the other stuff to move around visually. Just when stuff appears, make it bounce, make the other stuff being pushed around and stuff like that. On the other hand, if you don't want to make a big visual impact, if you just want to pretend like the stuff was there all along, like in the wine list example, just give it a smooth fade in and don't move other stuff around, because that will be noticeable to users. All right, so basically you can animate views, you can use layout animations, and you can animate on fragments or activity changes. I'm not going to go through this. This is a really heavy slide. If you want to, please do come back to it later. I'm just going to touch briefly upon what APIs there are to use, because it has changed over time and it might be a little bit confusing. Essentially on views, there are two ways. There's the good old one that's been around since API level 1, which doesn't actually change anything. It just draws the view very differently. And then there's the property animation, which came with Honeycomb, where you actually apply transformations, and you can use that not only for views, but for anything. And there are layout animations. The old one plays once when the layout is first laid out. It applies the same animation to all of its child views, but at different times. And there's the layout transition, which we saw, where you can change stuff in runtime, as you saw in Google Keep there. And the last part of activity and fragment transitions. You may have used the override pending transition method on activity. If you did, don't do that anymore. It's sort of unnecessary since Jelly Bean, since you have the activity options to use, in which you can specify a bunch of animations. You can just store them into a bundle and send that with your intent, so you'll have some greater control of exit and enter animations. And then there's the fragment transaction API, where you can, which you use to commit to put in or take away fragments. And adding to that, you can also specify some animations to use there. So that's the quick walkthrough of that. When it comes to animations and transitions, as I said, I've said it a number of times, do provide smoothness, snappiness, help the user understand what's going on, and use the APIs we talked about. What you don't want to do is introduce unnecessarily longer delays that are noticeable, and you don't want to do too much. Don't get too carried away with the animations just because you can. you may want to get a second opinion from someone else, because what may look very good and very good to you during implementation time may be absolutely terrible in runtime. You think you've done something really snappy and really cool, but then an end user may just be annoyed by that if it takes too long. So take a step back and ask for second opinions. That's my tip. All right, the last third is about signature UI elements. And what I mean when I say signature UI elements are typically custom elements made from non-standard building blocks, which you can use to make your application stand out from the crowd or solve a really specific problem. And the stuff that I said before still applies. You want to think about movement, you want to think about perceived performance or actual performance, and you want to think about usability and learnability in custom views more than ever, because this is a new component that the user may or may not be familiar with. So yeah, that's really important here. Few more examples, video examples, which should launch all at once. Yeah, they do. Oh, there you go. So from the left, that's a Swedish application made to measure the speed of your internet connection. So this is my home Wi-Fi. As you can see, the gauge goes up and down there. Doesn't actually provide that much function, but it's really nice. It makes users come back. This thing, people run this over and over again. So yeah, more nice than useful, perhaps. The one, the Flipboard, I guess most of you are familiar with, where they've actually built a whole app or a whole concept around this visual effect of flipping. Flipboard without the flipping wouldn't be so much. So that's a real signature UI. Third one is a drawing app called Sketchbook, which actually uses this to solve a problem in a very elegant way. So you have the problem that in a drawing application, you typically want the whole screen to draw on, of course. You don't want a lot of tools in the way that you want to draw. But at the same time, you have some rather advanced settings to utilize that need to go somewhere. So they've implemented this little wheel that when we press it, it expands, and you have all your tools there. You can adjust the colors and the thickness and the drawings and stuff like that. So that's really elegant. That's really solving a problem. And the last one is another Swedish app. This is a kitchen timer. So you spin your finger around, you spin this dial around to set the time, and you press it to play it. Doing it, but most of all, it's fun and pretty, and it gives some character to the application. Right. So what you want to do when it comes to signature UI elements is to take advantage of the new layout framework that is in Android, sorry. You don't go reinventing the wheel every time, but you want to reuse the powerful mechanism that's already there. So finding a good way to plug in extending view or view group, that's really key in this context. So there's a good framework that will do the layouting, the drawing, and all the touch handling for you. And also adapts really well to screen sizes and screen orientations. So if you, when you find yourself in the need or in the process of implementing a custom view, do this with care. It's really powerful, and if you do it right, you don't have to do that much work yourself. So what you're going to want to do is you want to focus on one or a few UI elements. Don't touch everything. Just don't f around with it. If you do one or a few custom components and you plug it into the Android view framework, the rest of the application is bound to keep working because it's a regular view or a view group. So as long as you fulfill your commitments that come with that, the rest of the app is bound to keep working and maintain the maintainability of the key word here. Right. So to make it a little bit more concrete, I'm going to show you a concrete example of this. This is a custom view group. And essentially, this is the really short version, 8,000 word tutorial available on our developer blog. So I'm not going to go into too much detail here. If you're interested, there's a link at the end so you can go in and check the entire tutorial. But essentially, this is it's a custom view group. It extends linear layout. And it, as such, it can hold any items. It can be in any item. It can scale to any size, and it handles it makes good use of the existing vanilla code. So as you can see, this is a short code example. I'm just showing the key parts here. Oh, actually, I'm going to show you a short video of what it does before. So what it does is essentially that it holds a bunch of elements that are bound to keep working as they are. But when you press outside of those, so when you press something that essentially isn't the buttons in this example, it's supposed to shred. So as you can see, if I touch these buttons, let's say this button does nothing, it does nothing. But when you touch outside of it, you get this quite different effect. This is far from a linear layout, or your regular linear layout anyway. So this is a project that we made, that I made as a prototype for the new lock screen that we are using. So this is essentially the foundation of the Xperia lock screen. So, as I said, it extends linear layout, which means that when you include this in your XML, in your layout XML, it can use all of the attributes specific to layouts, such as to linear layouts, such as gravity and orientation. You can put all of your text views and your linear layouts and whatever you want inside of it. So that's really neat. So up until this point, you don't have to care that it is a special one. So the developers using this can actually treat it as their regular linear layout. So the only stuff that we actually do change, I am extending the on-touch event, as you can see. I do very little in it. Just want to keep track of whether you're touching the buttons or if you're touching the blinds view. So yeah, basically reusing the touch handling as well. As you know, if there are buttons that are being touched, we will never reach the on-touch event callback in our own view. All right. So this is the part where something actually happens. It's only the dispatch draw method. So I check if we're in blinds mode as I registered in the touch events. And if we're not, we're basically sending the call onto the linear layouts dispatch draw. So we're not touching that. We're trusting that to do its own layout and its own usual drawing. It's only and only in this mode, if we are in the blinds mode, that we do route the call to our own method, where we do a lot of stuff. So essentially, I have done very, very little in the usual case, where it just lays out and you press all the buttons. Whereas in this special case, it routes to draw blinds. And draw blinds, that's where the magic starts. That's a big thing, but I'm not going to go into that right now. So essentially, we've accomplished all this, but still touching very little. So this is bound to keep working with whatever you put into it, or whatever screen you run it on, or whatever is around it. So it's sort of it's a pretty elegant approach to that. Right, yeah, and I wanted to point out how there's an absence of layout methods, which leads to exactly what I said. There's a whole framework doing all of that for us. So when it comes to signature UI elements, what you want to do is focus on a few elements, because this is probably the most costly of the three approaches that we've discussed. This is quite costly, and you want to limit what you do. You don't want to make a ton of custom views. You want to do typically one or a few in your application. It depends on your application, of course. Maybe you want to do none. Maybe you need to do 10. That's really up to you in your application, but you should be aware of it to make conscious choices. So probably focus on a few elements and think a lot about modularity and maintainability. Don't start out just extending view and go crazy. Just look what's there to extend. Do that wisely. Yeah, don't fill it with everything. Okay, that just about sums up the session. Before we end, I'm going to say a few words on what approach you want to go with. As I said in the beginning, it's about how much you can get for how little, essentially getting a good return of your investments. So you can basically see these as a sliding scale, or as a few different levels. It's definitely cheaper to think about perceived performance, and basically everyone should do that. That should be a hygiene factor for any app out there. You want a well-performing application. The transitions approach is, of course, slightly more expensive, and you may not always need that, although most apps should. And when it comes to signature UIs, not every app is going to need to have that, and it's also the most expensive approach of this. So you want to find your level. That's what it's all about, to make a conscious choice about what level you're at, and to be able to spend your time doing what actually gives you a return. And yeah, I should mention that as well. If you're on top of this, if you're doing a 3D application or a specific game or something, then you just want to draw directly to the canvas, and these approaches basically don't apply. I mean, the essence of them do apply, of course. You need to think about performance transitions and stuff like that anyway, but you're not going to be using Android's view framework for that. So to sum up this entire session in one sentence, or two sentences actually, it is that you really can do a lot with a little. You need to choose wisely what you're going to spend your time and energy on, and you need to make active decisions to find the right level. So I hope you may have gotten a few ideas on what to look into when you get back home. We've only just been scratching the surface, as I said. I could have held 3 separate sessions on this, but that seemed a lot. So if you have any further questions after this, we're going to have a quick Q&A, of course. After that, please do get in touch with us on our developer blog or me directly or whatever. Like Marcus said, we do have a plane to catch, so we're not going to be hanging around for a while, but for a short while we'll be here. All right, so that's pretty much time for the Q&A then. This QR code goes to our graphics tutorials on Developer World, and there's the specific link to the Blinds View tutorial as well, if you like that. You can connect with us socially on Twitter or Facebook. And I want to also promote this link to Google here, developerandroid.com/design. That's a portal that's become really, really good over the last while. It includes a lot of guidelines, design templates, design patterns, a lot of introduction and code samples to some really useful examples. And if you want to feed something back to me personally, that's my email address, so do keep in touch if you feel like it. All right, that sums it up for me. Thank you. Thank you. Yeah. So the question was about the slide on return of investment, I guess, and I should clarify that more expensive means that it will be more expensive in terms of your time, the time you spend developing that, and in the case of you're hired by someone, the number of dollars your employer will gonna have to provide. Yes.
Which is the most common bottleneck that you can find in an application that is very on the UI today, that uses the Canvas API?
Sorry, was that?
Which is the most common bottleneck that you will find? Slow internet connection, misuse of the cache, CPU waiting for something, floating point unit not responding. Which is this?
Okay, so the question was, I think, what the most common bottleneck is in regular Android views, right? Not GL views, not Canvas views. Yeah. Okay. Yeah. That's hard to say. There are so many opportunities to mess up. Essentially, I think you're waiting for, I say read operations, database, reading from database or reading from file system or something like that. Not doing that in an asynchronous fashion. That's probably the most common thing you'll see, I think. Or perhaps not handling that nicely enough so that you're waiting, but you're not doing something in the meanwhile. I think what's key here is to get something on screen ASAP and then come back to touch it up later. I don't think many developers do that. I think you try and do something, then it takes too long, so you get an ANR in your application. So you try to fix that by spawning this up into a different thread, which will of course work, but it will not look better on screen unless you have some sort of placeholder data or something there. So that may also be a common mistake. Yes?
In your opinion, how long does it take before an animation gets too long for the user? I mean, we
seen that in Windows phones, many people complain because animations are too long.
Hmm.
Too much place.
Yeah. Okay, so the question was how long an animation can be before it's too long, before it gets annoying to the user. And that's, of course, hard to give an absolute answer to. But from the wine list experiment we did here, if I would apply that animation, that 100 millisecond animation to the first case where there actually was no delay, then 100 milliseconds would certainly be too long. But in the case where it takes a second and a half to load it, then adding another 100 milliseconds sort of just adds to it. So it's really hard to give a concrete answer to that one, but which is also, it's so subjective and it's so much about perception. So I think the best way to handle that is to have second opinions. If you have it, you want to set together a focus group and do some solid user testing. Not everyone has the resources for that, of course, but you need to let people try it out and see what they say about it, essentially. Yes?
I'm wondering about the asynchronous data abstraction example you gave with the 150 millisecond delay. Is there a traditional design pattern that's useful for that?
So the question is if there's a useful design pattern to work around for the 150 millisecond delay, right? Yeah. And there probably is, yeah. Now, there's probably not just one, there's probably a bunch of them. As I said, there's the async task, which people tend to use a lot. I know some people don't like that for various reasons. I guess the most basic thing is to just spawn off a new thread. Then again, that will make a lot of threads. So there are the examples I gave with the async task and the handlers and the services if you're really consuming. Some of them work in a fashion where they queue up, other ones don't, they run in parallel. So it really depends on your situation there as well. So it's hard to give a straight answer to that one as well, I'm afraid. So. Yep. Oh, there's two of you in this.
Do you have any tip that we don't get lost with all the threads that we have to manage?
So if there are any tips on how to get lost in your threads, what's been working best for me, that's pretty a low-tech answer, but what's working best for me is actually to draw it on a piece of paper. To really draw the call. Okay, here I'm spawning off this thread, there's another thread, they're touching these objects. Here it releases the locks if you have locks involved in it. To just visually see what happens. That's what works for me. I guess you could get other answers if you ask other people, I suppose. Yeah, the one behind.
So you talked about the override pending transitions in activity options,
Mm-hmm.
which is a newer API. Did you notice any performance boost in the transitions in the animations? Is it any better?
So the question was if there's a performance gain in using activity options over the override pending transition, right?
Same transitions, because I know there's some new ones with the
Right, so if I use the same transition in both examples. I haven't looked into that much, to be honest with you, but no. I've actually never had any major performance issues with override pending transition either. So I can't say that I did, no. Anyone else? I can't see for the lights here, but I see no hands. Oh, there's one, sorry. Yep.
For example, you have the smartwatch and it's really small, so if we have really resource constrained screen, how do we have really clear things, but when we need to display a lot of things? Do you have any tips on that?
So I think the question is about how to design for a really small screen, such as a smartwatch. Yeah, keep it clean. Yeah, of course, that could be a session of its own, I think. But there's a book actually called Designing for Small Screens, which is pretty old but still applies. But I mean, from the top of my head, I would refer to the sketchbook example. I think they're making good use of this with the little expanding circles. So maybe you want to, at the same time, on such a small screen, you don't want to do too deep menu structures either. So it's tricky. It comes with some constraints. It does. But I mean, I think actually it's a bit of an obvious answer. But I think the best answer is to keep it clean and keep it really simple. only include the stuff and the buttons that you actually need to have there. Does that answer your question? Okay, then I'll hand the mic back to Marcus. There you go. Thank you.
All right, so what some of you have been waiting for, I guess, as well. So we've done a bit of prepping in here. So stands up. It's been a long day, right? So please stand up. Good. And under a few of these seats, you have a note. And the first one that comes up to me gets this.
Better hurry. Oh, it's a close call.
Yay! We have a winner! Anybody else? Yes?
Oh, I'm
Yes?
just welcome.
Yay! Alright.
Well done.
Alright, that was it. I only have this to do. Good luck next time. Alright, thank you guys.
Thank you.
Thank you.